welcome back to my continuation of where I left off yesterday. Before I begin this class, I would like to point out a minor mistake I made last time. So I forgot to explain where I got this A minus B angle, if I recall. So there is an angle that starts from the x-axis horizontal all the way to here, and the angle is A. And there's another angle that's a bit from the axis and then moves all the way here. So this is the line that moves with a certain angle and with a certain angle from the horizontal, and its angle is B. That means that the angle between them must be A minus B. Later, I didn't mention where I got this part, where I subtracted cosine of B minus cosine of A, and that I got from finding the difference between those two coordinates to find the total length that is covered for this base of the triangle. Likewise, the height can be found by taking the difference between this height, which is found through the sine of this angle, sine of A of this angle, this line, which will give us the height minus sine of B of this angle, which will give us this height, and then the difference in the height will give this height that is represented for this triangle. Today, we're going to be continuing with our proofs in our pursuit of finding cos75. And today we're going to be proving the cosine law. To prove the cosine law, we're going to use an algebraic manipulation. And we're going to use that. We're going to do that with the help of a triangle. So the trick is to find h squared in both cases, and the same way we're going to use the same method we used in the last class, and that is the Pythagoras theorem. It's an effective tool in many proofs in mathematics, but using the Pythagoras theorem, we find that h squared plus x squared is equal to b squared. Okay. We also find that h squared plus, this is a c below, because this entire side is c, and this is c minus x. So we're going to write plus c minus x squared is equal to a squared. Okay, now let us isolate h squared from both equations. I call this 2, we call it 1 and 2. So in the first equation, h squared will be equal to b squared minus x squared. And for the second equation, h squared will be equal to c minus x, a squared minus c minus x squared. And because these two are equal, they both equal h squared, then we can put them together, and we can make them equal to each other, which implies that b squared minus x squared is equal to c squared, a squared minus c minus x squared. Okay, now let us simplify that. A squared minus c squared minus multiply by everything in this parenthesis. So this will give us plus 2cx plus x squared. Okay. And we have b squared minus x squared right here. Because they say, then we can, okay. And the last part should be negative because everything changes when we multiply everything by negative into the parentheses. Because when we open this bracket, it should actually be c squared minus 2cx plus x squared. But this minus multiply everything by negative, yes, changing their sign. So this will be minus x squared. And adding plus x squared to the both sides will get this and this canceled away. So this could be simplified to, let me just show plus x squared. This turns to 0 plus x squared, and this turns to 0. Okay. Then b squared is equal to a squared minus c squared plus 2cx. Okay. And to get only positive and negative on one side, we can move this to we can move everything to the left side except a squared. So we can write that like this: a squared is equal to b squared plus c squared minus 2cx. And we're getting something that is looking very similar to this identity, this one I showed last time. And x, let me just write that clearly, 2cx. The x can also be represented through with the help of the angle right here, angle A. So cosine of A is equal to the adjacent, the side adjacent to the angle, which is x, divided by the hypotenuse, which is b. This implies that x is equal to b multiplied by cosine of A. So we can do a substitution and replace the x with cosine of b cosine of A. So this gives us a squared is equal to b squared plus c squared minus 2ab cosine of A. And because this angle is capital, then we know that the angle, the side opposite to the angle must be the one that is shown here. So if we're finding angle B, then we have to use side B in the pursuit of finding the missing side. Okay, and that concludes the proof. Thanks for watching, and I'll see you next time.